Okay, so we are continuing from class. So don't look at the other videos until you see this video because the other videos is a little more advanced. It starts off with example 5, which we didn't get through 3 and 4 in class. So this video is to get through 3 and 4, examples 3 and 4. Okay, so remember I told you all earlier today that if the degree, if the rational function, which is the p of x. This right here is the rational function, which is a function of polynomials. If it's not proper, meaning if the degree of the top is larger than the degree of the bottom, then we have to use long division to write. And how we write it is, when we use long division, p of x over q of x is going to equal g of x, which is going to be our quotient in there. And then we have the remainder, and then q of x is our divisor. Okay, and so let's do a quick review on, and if you want, because I'm trying to save time, so if you want to pause and write everything down and then go back over the video, that's fine. Okay, so a quick, let's go here first. A quick division review. So we take x cubed plus 1 over, we're taking x cubed plus 1 divided by x squared minus 4. And so we take our divisor here, and since there's an x term that's missing, I like to use a placeholder of 0x just to keep things a little more organized in my long division. And then in the dividend, we're actually missing an x squared term and an x term. And so I satisfied those by putting x cubed plus 0x squared plus 0x plus 1. Okay, and so from long division, you should remember, and hopefully remember, that you look at this value here and this, so the first term in your dividend and the first term in your divisor, and you look at the divisor and say x squared times what will give me x cubed, right? So x squared times what will give me x cubed? Well, it's x, and we line it up accordingly with its proper term, so that's why the x is over here. And then we take this x and multiply it by every term that's here in our divisor, and we'll have x squared times x. So I'm sorry, I hope I'm not confusing with all my arrows. It's very colorful though. But so x times x squared, or x squared times x is x cubed, 0x times x is 0x squared, and then negative 4 times x is negative 4x, and that's given here on this line. And then once we do that, we have to subtract what's in the parentheses, and so the x cubes cancel, the x squared cancel, and a negative, remember this negative right here is being distributed to each term, so that becomes a positive 4x plus 1. And since this degree here, which is a degree is 1, is smaller than the degree of your divisor, then you know that's your remainder. If this degree was the same or larger, then you'd have to keep divide again. Okay, a quick review on that. So now we can go back and write our integrand, x cubed plus 1 over x squared minus 4, as x, which was, this is your g of x, so that was your quotient there, and plus 4x plus 1, which was our remainder. And I went ahead and factored x squared minus 4 into it's a difference of squares, so x minus 2x plus 2. Okay. And now we can integrate, which I think I did on the next page. Oh no. Now we can set up our PFD, right? So now we can set up, I'm going too fast because I don't want to wait. I'm going too fast because, let's see, because I'm not trying to make this video too long, but by me slowing down now, I'll make it longer. I digress. Okay. Don't worry. All right. So now when we look at this, since we just wrote, so we just took this, our integrand, and rewrote it as x plus this quantity here. And so if we could integrate, right? So we can integrate, but so this right here is a straightforward integration. That's just power rule. But here we need to do a PFD on this. And so that's what we're going to focus on. Now, when we bring our integral back and have to solve our integral, we will have to take that x into account. But for now, we're just going to focus on this expression here and do a PFD on that. Okay. So here it is, and you guys know from class the first two examples we did how to set it up. You clear your fractions. All right, so that's your setup there, right? A over B, and again, you can switch A and B. You can switch where if you could have made that x plus 2 and made that x minus 2. It's just up to you and your preference. Then you clear fractions by multiplying both sides by the common denominator, and then you find your zeros. So the zeros are -2 and 2, and then you just solve. So remember, if you have some things, so on the left hand side, wherever you see an x, you plug in 2, and on the right hand side you do the same. So when x is 2, the left hand side, 4 times 2 plus 1 is 9, and then the right hand side, when x is 2, this goes away to 0, and this right here, 2 plus 2 is 4, so we have 4a. 9 equals 4a, and so a equals 9/4. Okay. And then for x equals -2, now we have a going away, right? And so now for x equals -2, that goes to 0, and we're left with the left-hand side. I'm sorry, the left-hand side, 4 times -2 plus 1 is -7, and then -2, since this goes away, that's canceled. When x is equal to -2, over here we have -2 minus 2 right there times b, and so b equals +7/4. Okay, so now we can integrate, okay? And again, remember, we have to bring back that x, right? That was part of our integral, okay? But although we didn't have to do a PFD on it, that was still part of our integral, okay? And plus the integral, and actually, you can really skip this step. You can go straight from here to here if you wanted to. I just like to show it in case some people are still having trouble understanding this. I like to show step by step, but you really can go straight there, okay? And so let me just go. So again, remember that was our A and this was our B, and so we just put that in. Then we can take those. So when we integrate x, that's power rule, so that'll give us x squared over 2. And then for the other two terms, we pull out the 9/4 here, and that's the integral of dx over x minus 2, and then pull out the 7/4 because those are constants. And then this is our nice natural log. So the integral, Dr. Bohm getting the points marked off. The integral of x cubed plus 1 over x squared minus 4 dx is equal to x squared over 2 plus 9/4, the natural log of the absolute value of x minus 2, plus 7/4 times the natural log of the absolute value of x plus 2 plus c. Do not forget your plus c because this is an antiderivative. All right, the last thing, we have a couple more slides, but the last thing on this video, so now after this video, you can go watch the other two and take your time and make sure you watch them. Don't wait to the last minute because it's a little more involved. That second method is used more. I know we didn't have a chance to we got most of it done, but you can see it could be a laborious task to do. So don't wait till the last minute to do your homework. I'm reiterating that. Okay, so what if we have linear factors, but if one of those factors repeat, right? We didn't talk about that because that first process is if they're distinct linear factors. So now we're saying that we have something repeating. And so what you have to keep in mind is that each factor contributes to the following sum of terms to the PFD, okay? And so the setup for repeated factors is this. I like to say you're sort of building up on it. And so when you break down your PFD, so we have on the left hand side our integrand, and then on the right hand side we know we can set up the a over x minus 1, but now we have plus b over x plus 2 plus c over x plus 2 squared. So you see how we build up, because if you think about it, what's going on is this. And so assume that we didn't have, so assume, I can erase it. Assume we didn't have that term, right? So assume we wanted the PFD to be x minus 1 a over x minus 1 plus b over x plus 2, right? So then how would we build up to that x plus 2 squared? So we're building up into that x plus 2 squared. So if I change that 2, and again, you don't need to write this down, but if I change that 2 to a 3, then this would be plus d over x plus 2, right? And then it would be cubed. Okay, so you guys see that? So you build up onto that, okay? And if you still have questions about that, make sure you look in the book on PFD, okay? Okay, so now that we know how to set up if we have repeated factors, the process is similar. We clear our fractions, okay? So you might want to actually, from this point, I would pause the video, especially if you're having trouble understanding this. Pause the video and see if you can, so, you know, use some scratch paper, don't necessarily put in your notes, but see if you can figure out the terms, and actually you'll see something. And this is what, so pause it and try to do that, and then go on to the next. Okay, so we cleared our fractions, and our zeros now are -2 and 1, right? And so when x is equal to -2, and of course check my algebra, make sure I didn't mess up, but when x is equal to -2, we have c is equal to 5, and then a is equal to -2/3. But what's the problem? We still need to know what b is, right? So we only have 2 zeros. So this is where you can either use, which I'm not going to do because in the other 2 videos I used the second method. I'm not going to do now. So you can either use that second method or do an extension. Look at that. And this is, I actually, the second method is nice, and I like the process of it, and it can be helpful as you will see in the next videos. But I like to call this method 1 extended. And so method 1 is finding the zeros. But now we can let x be anything. Since we have 2 of our values, we have a and c, we can let x be anything, any number, and solve for b, right? Because now we only have one, we'll just have one unknown because we know what a and c is. So what I'm going to do, and then I should be done with this video because I didn't want to go over 10 minutes, but I'm already, let me stop talking. Okay. So what I want to do is just find, and you can pick any x value you want. My advice to you is to pick something that's easy. So we already have 1, but we don't have 0, right? If 0 isn't a 0, so if it's not one of your zeros that you've already used, then just use 0. Or just keep it simple. Keep it something small. So let's see what happens when x is 0, okay? So when x is 0, the left-hand side becomes -9. And the right-hand side, well, a is -2/3. So it's -2/3 times 0 plus 2 squared. So -2/3 times 2 squared. Plus b times 0 minus 1 is -1. And 0 plus 2 is 2. And then plus c, that's going to be -1. Okay. And I want you to finish this because I really want to cut this with the last slide. So definitely pause the video here and finish solving for this, solve for b. Pause it now. Okay. So welcome back. B, as you probably already found, B ended up being, if I did my algebra correctly, I believe it ended up being +2/3. Okay. If not, please let me know. But I believe that's what it was. So now we have, and actually now I'm going to have you guys finish on your own. So make sure first check to make sure B is 2/3, and then stop the video and see if you can finish integrating. And now I'm going to, on the next slide, the last slide, I'm going to give you the answer. Alright, so your final answer for the integral of 3x minus 9 over x minus 1 times x plus 2 squared dx should have been, and again, let me know if something's incorrect in my work, -2/3 the natural log of x minus 1 plus, oh wait, I think I used, Wait, let me see something because, wait, hold on. Okay, no, I just wanted to make sure what I did on the video matched up with what my notes have, because if my A's and B's and C's were different, then this would be different, but I believe I used the same, so everything should be fine. Okay. All right, so I'm done with this video. Now you can go look at the other two, and I will see you all next week. So again, I will have limited internet capabilities, so you can send me an email. I might not respond right away, and you can message the group, and just use your resources. Okay, see you all Wednesday.